Hello everyone and welcome back to CS with Mr. G. In this lesson we are looking at this term library routines, which comes under the programming unit, Unit 8, which we are making steady progress in learning lots of different algorithms and some of the fundamental topics when it comes to programming, and in particular the Paper 2 exam in iGCSE Computer Science. So just a reminder, we are currently here, and if you have forgotten, I'd just like you to recap and think about Paper 2, including these 4 topics here. I've mentioned briefly that Unit 7 and Unit 8 do overlap in some cases, and some of the topics in today's lesson we might have seen before in Unit 7, but would have been specifically in pseudocode and not in Python, which is what we will look at today. So in today's lesson, we need to look at this term library routine, which includes these 4 routines here: mod, div, round, and random. And we need to know what these functions do and how we write them in Python if we need to use them in a scenario-based question in your Paper 2 exam. So just to start us off, let's look at the term library routine in general. And what it is, it's a pre-made set of instructions which already exist and that we can use in our programs, so we're not having to reinvent the wheel or write lines of code that already exist in the world of programming. These routines or these functions are pre-built. We don't know how they work. We don't see the code inside. We just know that they take inputs and will give us outputs as a result. So these routines are useful when we give it data, because it will do something with it and then give us it back after doing something in particular with this data. So these 4 we've mentioned: mod, div, round, and random. You might recognize mod and div from Unit 7, but we'll go over specifically in Python so we can see how we use them in a programming language. So we'll start off with mod, also known as modulo, and modular division returns the remainder when we divide a number by another number. So as I've mentioned, this has been covered in Unit 7, but just as a recap, we have to think back to basic maths and the remainders when it comes to division. And in this example, we are doing 10 divided by 3, which, as we know, it goes 3, 6, 9. So 3 3s make 9. And then obviously there is 1 left over to make 10, which is the first number. So 1 is the answer. So 10 mod 3 would give us 1. And how we write that in Python is with the percentage sign here. I will go over the pseudocode alternatives at the end, but in Python, we do the percentage sign with the 2 numbers either side of the percentage sign. And we're going to store that in this result variable here. So the answer of 1 will be stored in the result variable, and then I can just print it out. And if you give this a go yourself, you should see that the output is 1. Mod is a very useful tool when we're checking for odd or even numbers. And again, this is something that's been mentioned in Unit 7. But why it's a useful tool is that any number mod 2 that gives the answer of 0 would prove that that number is an even number. All even numbers divided by 2 divide perfectly, leaving no remainder in any circumstance. So the answer will always be 0. So that way we can use a basic if statement, and if a number mod 2 equals 0, that number is even for sure. Otherwise, we can print out it's odd, because anything other than being equal to 0, then it must be an odd number. So if we did 12 mod 2, again, that would equal 0, because 12 divided by 2 is 6 with nothing left over. 14 mod 2 equals 0. And this would go on infinitely for all even numbers in our number system. Next, we have div, also known as integer division or floor division. And div simply gives us back the whole number part of the division, ignoring the remainder and ignoring any decimal points after the calculation has been done. So in the same example, 10 divided by 3 would be 3.3, but we simply forget the 0.3, we forget the remainder of 1, and the answer would simply be the 3, which is the whole number part of the answer. So the reason why it's called floor division, and this might help you remember, is that you round down. For example, 12 div 5 would equal 2 remainder 2, or 2 point something or other. But basically, we round it down to the whole number, and it would be just simply the 2. One more example, just to confirm, we could have 9 div 2, which equals 4.5. 4.5 rounded down is simply 4. So again, div or integer division returns the whole number, discarding any remainders or any decimal points. Next, we have round, and the round function gives us the ability to round a number to a specific amount of decimal places that we wish. And how we do that is we simply use the word round. That's our keyword here. The number that we want to round down goes first in the brackets. If we think back to our last lesson, this is known as the parameter. Then we have to put a comma and then the amount of decimal points that we wish to round it to. So in this case, I'm going to round this to 2 decimal points. And after I've done so, the answer will be stored in result. I print out the result, and the output in this case will be 3.14 as we round down to 2 places. Likewise, if we change this to a 0, this would simply round it to 3. And again, you set the amount of decimal points you want to round it to in this position here after the comma within the brackets. So the round function, nice and simple, and we will go through the pseudocode alternative shortly. Next, we have random, which can be used if we ever need to generate a random number. Now, random isn't built into Python, hence why we have to use this word import here. And that will do is basically give us the set of tools that random brings. So within our programs, we can do things like generate a random number. So don't worry too much about this term import and then random. This is just basically two words that we have to write at the beginning if we wanted to generate a random number. The same thing again, we create a variable called result, and inside this variable is going to equal a random generated number as we use the random module full stop randint, which, if you can guess, is short for random integer, which as we know is a random whole number. And then in our brackets, we put our lower and upper boundaries of the random number that we want to be generated to fall within. So in this example, the random number will be between 1 and 10 inclusive, so it could be 1 or 10 as well, but it could give us back any number between these numbers, so it could literally be 1, 2, 3, 4, 5, 6, 7, 8 or 9 printed out in this result here. Likewise, if we change this to 1 and 100, it could be any number between 1 and 100, which will be printed out at the end. So generating a random number does require you to use this term import random, and then it's random.randint. In pseudocode, it's much easier, which we'll see on the next slide. So as you can see, mod is written as mod in capital letters with the two numbers in the brackets, with the first number being the number that's being divided, and the second number with the amount that it's divided by. Div is simply div in capital letters. Same thing again with the numbers in the brackets. Round is much easier than in Python, as it's simply just the word round, and the brackets remain the same. It's the number that we are rounding and the amount of decimal points that we round it to. And random is also very similar. The keyword random followed by the lower and upper limits, which we want our random number to be between. So this would include the number 1. It wouldn't be 0, that's a mistake on my behalf, but that would generate a random number between 1 and 100. If we were simulating a dice roll in a game where a dice has 6 sides, we simply import the module random. We use the random.randint with our lower and upper limits. We then generate a number between 1 and 6. This gets stored in this variable die roll, and then we can print out you rolled and then the random number that was generated in this part here. So really simple, just like the previous 3. And then finally, just to put what we've learned into practice, let's write and test a program in Python that will take 2 integers, we'll label them as A and B, and find a mod B and a div B, and then print out the results. Then we're going to create a random number between 100 and 300 and output the random number. So first of all, we'll create a variable called A, and this will be an int input as it's going to be a number, and we enter first number. Then we create a variable called B, so I'm just going to change this code, enter second number. Then I will create a variable called mod result, and this is going to contain the answer of A mod B, which in Python was a percentage sign, and we can print out our results and see what happens. I will do the div result as well, so div result equals A 2 forward slashes, and this was B as well. Then I will print the result of the division. So let's give that a run. I will enter the number 10, like from our example, and then 3. And as we can see, the mod was 1, as this was the remainder, and 3 was the floor division. Just for clarity, I could have put a string just to say that the mod result was this, and the div result was this. Let's run that again and put 2 different numbers in. This time we'll do 20 and 6, and 6, 12, 18 would leave 2 as a remainder. And then 6, 12, 18 means 3 times that it goes into. And then finally, to generate a random number between 100 and 300, we import the module random. We create a variable, let's just call it random number, and this will equal random.randint. Set our lower and upper limits, which were 100 and 300, print out the result, give this a run, and hopefully it generates a random number between 100 and 300, and it's given us 196. If I just keep running this, 191, 280, and 293, and it will keep going with random numbers between those limits. And like I mentioned at the beginning, the code inside of this library routine, we don't need to see, we don't need to know how it works. All we care about is that a random number is generated each time it's run. In this case, it does. So that's all for today, guys. Hopefully you can work through and tick these off, showing an understanding of each one, and hopefully remembering how to use them or when to use them in a scenario-based question. So as always, guys, thank you very much for watching. We are nearing the end of Unit 8 with a few more concepts we need to go over before we have some practice questions putting all of our programming skills together with some past paper questions for practice. So thank you for watching, and I'll see you next time.